Okay, this is the day three. Okay, so in the day three, we'll be looking at separation techniques. Okay, so that's it. So I actually said here that the first one is sieving. Though jamb didn't ask us to work on sieving, it started from crystallization, but we'll just look at sieving because of those of you that will write WAEC. It separates solid particles of different sizes. Example, Gary processing. You sieve and you remove the unwanted parts. So that is what sieving does. So it actually separates solid parts of different sizes. You can see when you see Gary, you see that unwanted parts are the solid particles, okay, that of different sizes. The larger size will remain there while smaller sizes will go down. So that's it. Next one is decantation. It separates a mixture of liquid and a denser solid particles, which separates what into what two distinct layers. Okay, on standing. Example is we have akamu, okay, and water. So I can also have a clay soaked in water. So when you look at it very well, you see that they settle at the bottom. So the water, the liquid part is being separated. Then let's look at filtration. Filtration is what jamb actually wants us to work on. So filtration is part of it. So it separates insoluble particles from liquid through the pores of the filter paper. For example, suspension of chalk dust in water. So that's what it separates. So for example, I mix chalk dust and water, you see. So when I separate it, I pour it inside the filter paper. Okay, we have what we call filtrate filter liquid, we call it filtrates. Then I have what we call residue. So residue is the one that remain. You can look at it very well. The residue is the one that remain in the filter paper, while the liquid portion is called what? The filtrate, in case they ask. Okay. Now the next one is crystallization. So what is crystallization? Is used to separate salts which decompose easily on heating from their solution. So that is the difference between crystallization and what? And evaporation to dryness. So it actually separates salt that decompose easily on heating. Is that okay? So that is the reason why most of the crystallization, the salts are being separated, is always having that's having a water content in it. You can see 5H2O, 7H2O. So it's used to manufacture of drugs and sugar. Okay, where purities of substances is important, so we use crystallization. Okay, so that is it. Then you can see the crystals. Okay, as they cool down, the crystals are formed after being heated. As they get cold, the crystals are formed. Next one is what we call fractional crystallization. So what is it? It separates two or more crystals solid based on their solubility, difference in solubility of the same solvent. Example is potassium nitrates and sodium chloride. So that is what it separates. Okay, so we actually use to separate solid of different have different solubilities. So that is it. So next one is evaporation to dryness. This separates a dissolved solid from a solution by heating the mixture to dryness, so that the liquid portion with a lower vapor pressure than the solid is removed from what? From the solid portion. Example is salt. Salt when being heated to dryness, okay, the salt content, that's the water solution of salt being heated to dryness, the salt remains while the water goes away. So next one is distillation. Distillation is used to recover a solvent from a solution. Okay, in other words, two liquid of widely different boiling points, example ethanol and water, is being separated using distillation. Is that okay? So they are being heated. The one with lower temperature will go out first, while the one that has a higher temperature will remain in the solution. So that is it. Sublimation is when a solid is being heated directly, then turned into gaseous state without passing through the liquid phase. It's called sublimation. Example is iodine, benzoic, and sulfur. Okay, and iron 3 chlorides and ammonium chloride. Please note the example. The examples is very important because that's where they can ask the question from. Okay, the characteristics and the examples. Participation or precipitation, sorry. Precipitation uses the property of difference in solubility of a solid in different mixable liquid to precipitate the solid. Example, okay, iron 3 tetraoxosulfate is soluble in water and insoluble in ethanol, so it can easily be separated. Okay, so chromatography is another one. It's a method of separating constituents of a mixture by taking advantage of their different rates of movement in a solvent over the absorbent medium. Example, separate what dye and ink. Okay, dye is in colored ink. In medicine, to analyze blood or urine and identify component of petrol. These are things that we use. Then separating funnel, okay, is actually separate two or more liquid with different densities. Okay, but let's look at chromatography again. The principle of chromatography is partitioned, okay, in paper chromatography. There are two phases. One is the stationary phase and the other is the mobile phase. Here, water is trapped in the paper, acts as the stationary phase, and the solvent acts as the mobile phase. So know the mobile phase and the stationary phase. Okay, thus as the solvent moves, the component in the mixture also moves depending on their what, on their speed. Is that okay? So in this way, the component is distributed between the mobile and the stationary phases. Okay, so for column chromatograph, the movement of the molecules or the absorption rely on what we call charge of the molecules. The charge of the molecules determines the movement of what, how far it will go. So we have the solid stationary phase, which may be silica, or the liquid what phase. These are all about what the separation technique that JAMB actually wants us to look at. Okay, so study it very well. They're easy to answer some questions in your past question. Thanks.